So this talk is about modular monolith architecture, and I'll start with a little bit info on me. Martin Säfsten is my name. I'm a full stack developer, and I am been working in the .NET area for many years. But I always like to learn new things, so I have been dabbled a little bit with everything, PHP and native app development, and yeah, a little bit here and there. And the past 2 years, I've been leaning towards more interest in architecture and also developer experience. And when I say developer experience, I mean about automated processes, about testing, about code quality checking. All of those domains is I've been setting up a few systems like that myself, and I'm always I like to have happy developers, because if everything is working with them and our tools for them to use, and everything is working smoothly, then that's the best way to sort of have a good productivity, and just having everything. I think the most important thing for developers is to be happy, and good tools and good structure and good architecture to have them able to do a good job is one of the keys for that success. So I am interested in that. I'm passionate about that. So and this is one of the areas that I like to get involved in details, and it's software architecture in general. And there is no real clear definition of what software architecture is. I think most of you would have some rough idea what you think that software architecture is, but there is no like scientifically defined sentence or couple of sentences this is software architecture. But some have tried, and I mentioned 3 here in the slide that are some attempts at somehow defining the broad thing that is software architecture. I like the last one is, I think, my favorite, because it really is the important stuff. It's the ones that are when you choose an architecture 2-3 years down the line, that's going to be probably the hardest thing to swap out and change. So whatever the important stuff is with the decisions when you're designing a system, that's probably architecture. And it could be code based, it could be infrastructure, and everything in between. But it's the really tough decisions. That's basically what I think of when I think of architecture. And I want to sort of get everybody on board on the baseline of my thinking of architecture and sort of the categorizations of architecture. And there are hundreds, thousands of defined architectures out there, but most of them categorize them in sort of a few columns. And technical separation is one of them, and domain separation are 2 of the big categories that most of the widely used architectures are defined as. And the technical horizontal layers is if you've done sort of programming on like in school, or maybe basic tutorials, or maybe legacy systems. It's very common to find these sort of technical layers where you have very clear separation of front end, and you have maybe the API or the back end that talks to the front end, and then you have the database that is in the bottom, and everything is nicely structured horizontally. So the whole product is just big layers with where everything that is sort of roughly the same technical stack. So you have front end, maybe you have some sort of front end tooling, you have maybe SPA, a library or framework, and then you have the business code, and you have a .NET API that talks to the managers or services or something in the back end, and they in turn talk to the database even lower. And it's very neat and clean. Everything is organized, and this is a very simple way to structure it. And one of the big pros about this is that when you have all of the sort of same code-like things, you have like all the database code is in one place, then you have a really good way of reusing stuff. You can do helper methods, and so everything, reusability is a big part of why this is such a widely used thing, widely used architecture. And consistency, it's everything is very organized around the technical aspects. So it's very easy to stay consistent, and you have all of the code that you have. Say you have like 1,000 database queries. All of the queries are there for you to look at if you want to see how should I do a query, what should the code look like. So it's easy to keep consistency and keep every code, all the code looking roughly the same. So the pros of technical separation is there, of course, but there are also cons, and the big cons would be that the tight layer coupling is that you have the presentation layer that talks to the API, and then the API talks to the database. Breaking that chain or doing anything else with that with the communication, it sort of becomes either impossible or it would break the architecture. So you're sort of forcing everything into that pattern. The whole product needs to be sort of this pattern for it to keep this architecture. So the layer coupling is very high, and I think a lot of you have worked in maybe large legacy systems that uses somewhat sort of this structure, and since over time this sort of layering also, it tends to become sort of this big mess of dependencies and usages all over the place. So it's a very common thing for this to sort of create this big ball of mud, is a term that are used a lot in architecture circles. Big ball of mud, just a big mess that you're afraid to change anything because you don't know what it will break somewhere else, because everything is sort of interconnected somehow somewhere. So small change there, it'll be fine. My bug is working, the new feature works fine, but somewhere all over on the other side, something that hasn't been touched in years, that could instantly break, but nobody notices it because, yeah, it's maybe not a very widely used system, or you don't have the necessary test coverage to check all of the system. Maybe you have a lot of manual testing to sort of cover, because you have a lot of bugs that are creating side effects. So this sort of has a tendency to over time grow into a big ball of mud, and the changing it is scary, and you have to compensate with bigger testing capabilities, maybe to cover up, to compensate for the bad structure, or the sort of messy structure of the system. And slow feature development is also a part of that. It's going to be, you don't want to change anything because you don't want to risk ruining anything else that you don't know. So a lot of legacy systems have this sort of have this structure, and most of them sort of they get a very spaghettification. They get a bit messy over time. That's what I'm trying to say. So the other way of structuring systems is by separating them by domain, or vertical slices. And domain, as a concept, domain is like it's a code that is somehow related to each other. They should be, if you want to separate something in domains, every domain should be somewhat cohesive in that they should have roughly the same responsibilities, all of the code within it. And the vertical slicing in comparison to horizontal slicing, which hopefully the diagrams show, is that you have like mini horizontal slices, but you move them into isolated vertical slices. So you have the presentation there, and you have the database, and you have the API. All of that is still that is not part of this level of architecture. The internal structure of a module or a domain, that's not the topic here. But this is a simple n-layered architecture within a domain. So each domain would be responsible for a specific part of the system that is somehow related, or it makes sense that they would be together. And it's about and the business alignment is basically that you have the the modules should reflect a natural part of the system, so that communication between the slices are as minimum is kept to a minimum. If you have two vertical slices that regularly talk to each other all the time, you have just a simple thing. You would have to say, all right, I'm going to add a user. All right, this is the user slice. I need to access the password service. Yeah, all right, I need to generate the password. So the communication between vertical slices, if that is high between modules, that could be a sign that the domain boundaries that were defined are wrong. And you want to minimize the communication between vertical slices. And that's sort of one of the guiding principles of vertical slicing, is minimizing communication. And agility is also a pro here. And this, in contrast to the technical slicing, because it's vertical sliced, everything is a smaller scope. Everything should be nicely isolated from each other, or at least roughly. Changing something doesn't mean that you have to have this whole big system that with dependencies all over the place. You don't have to consider all of that, and you don't have to have the fear of breaking that. A change in this module should only affect bugs in this module. That's sort of the one of the big pros of this, is that scoping everything, so you don't accidentally have side effects or minimize side effects. And if there are side effects, hopefully it's the same team that works on this. So you have your team that works on one module, and so if there are side effects, you have the team that knows the module best, or knows the domain best, that can hopefully minimize the side effects, the potential side effects. And cheap to change comparison to expensive to change. It's cheaper to do fast development in smaller parts of the system. It's easier to have automation. It's easier to have testing because everything is a lot smaller scoped. And the cons, of course, there are cons. All of the architecture is pros and cons. More complexity, of course. You have now, instead of having one big code base, one big project, one big front end, perhaps, you have multiple, and handling the communication between these, because there is no real world where they are completely isolated, because all of these domains need to talk to each other, because they are a part of one bigger thing. So communication is more complex, and duplication of code is also a big con. If you have separate teams that are working on the different domains, if they are isolated, then they can basically solve the same problem in multiple ways, because they don't have the same sort of common thing that they're working on. So every domain could have potentially solutions for multiple solutions for the same problem. So handling duplication is a company-wide strategy. You want to have some way of minimizing this. Maybe you have sort of cross-team meetings. You have cross-team people that are in meetings together and discuss common problems to minimize this sort of the risk of too much duplication. But in my opinion, duplication of code is not the enemy. It's nothing that should be completely avoided at all cost, and it's the worst thing that you could do as a developer, is duplicating code. I strongly believe that duplication, the risk of duplication is or the downside of duplication is a lot less than having a good, well-structured product. So some duplication is necessary and is okay, to a balance, of course. Everything is still balances, especially with software architecture. The next part of the sort of categorization of architecture is the monolithic compared to distributed. And monolithic is a monolith, big structure from ancient time. It's the core concept of a monolith is that it is one big thing, and when you want to update, when we want to release something from monolith, then the whole system is updated all at once. One big thing, one single deployable unit is one of the most common used terms for this. Any communication within the monolith is in process, which means that you talk to the different layers talk to each other with probably normal function calls, method calls, not a lot of network communication within the monolith. Could be integrations, of course, but that's the details. But the general idea is that you have in-process communication within the monolith. And for scaling this, if you want to have load balancing, for example, you can't take a single part of the system, just a small part, and just bump the process power of that. The most common way to load balance a monolith is to just duplicate the entire monolith. So that's one of the drawbacks, I would say, compared to the distributed, which I'll get to in a second. And I mentioned traditional style because before the modern world of containers, of Docker, of Kubernetes, of all of these nice tools that we have today, it was really expensive to have microservice or distributed architecture, because every part of the distributed architecture, every small subservice, it would have a separate computer. It could have a separate license fee for the database. So nothing was really prepared in the old days, which was not that long ago, but in the old days before all this, it was really expensive to have microservice architecture or distributed architecture. And it was the common way of doing it. The normal way of doing it would be to have these monolithic systems. You have one big computer, and you have the database maybe on one big computer. Everything would be sort of big under big licenses and would be cheaper. And then a couple of years ago, I'm not sure when, but in the last few years, maybe 10 years, the distributed architecture sort of like there was a big boom of this concept, because Docker and containerization allowed us to have build small things that were isolated and was easy to deploy and easy to duplicate, and all of the input and output was very nicely programmatically controllable. And you have systems like Kubernetes, which could take all of these small containers and build this huge, big network of smaller things, and how they would communicate and how would they load balance. So everything, all of the tooling sort of became available, and then the microservice revolution sort of exploded. So distributed architecture, multiple deployable units, compared them to the single deployable unit, so everything, you should be able to update one thing, and it should not create downtime or affect anything else in the system. So independent deployability means that you don't break stuff. You don't have to take down the whole system just to update one part. You have that flexibility. But the downside then is the communication between the services is somehow, it becomes a bridging between different processes, and they can be on the same computer. But most likely in modern cloud solutions, it's network-based. And network-based communication is it is what it is. It's not as stable as in-process communication, just by nature. So it's definitely one of the drawbacks of distributed architecture. And scalability and elasticity were needed, as I mentioned. It's you have that using the tools that are available for microservice architecture. And microservice architecture, that's not the only way of doing distributed architecture, but I will focus mostly on microservice architecture for this, because it's relevant for the modular monolith that we're going to come to in a bit. I mentioned the networking, that is one of the big drawbacks of microservice architecture. And there is a list that's called the fallacies of distributed computing, and it's not a very old concept. It is an old. It has been around for a while, and this is a list of simple description of why networking is hard. It's complex. It's unreliable for many reasons. And it's easy to talk about distributed architecture as the only reliable way to do, because it's the best. You can use Kubernetes, it's the best, but architecture is always trade-offs, always. And this is the negative parts of distributed architecture and distributed computing. So in contrast then, if microservices are the new thing, should you always do microservices? Is that can you Does everything new have to be in microservices? Is doing something in a monolith, wouldn't that to go back to the way things were before? Is that not the legacy way of writing the software? And my argument is that no, microservices is not the correct answer. Monoliths are the wrong answer. It's really not that black and white. Everything about software architecture is trade-offs. There are strengths and there are weaknesses to all architecture designs, and the only way to know which one is the right one is simply by context, by your specific scenario and your needs and the requirements from the business side. And you have technical concerns, you have languages, and functional. All of those are what should decide which architecture. You shouldn't select microservices just because it's the new thing. You should do it because it's the right choice given the requirements. And scalability, scalability, availability, testability, modularity, and maintainability. These are buzzwords, but they try to sort of. I added them here because I like them to be sort of the guiding principle for developers for when writing in a software that has an architecture. Is the code scalable? Are you as a developer able to scale and improve and expand the functionality of a system? Is the system testable? Are you able to have automated tests? Is it easy to write new tests and have it tested so that it prevents future side effect bugs? And is it maintainability? Is it maintainable? Is it easy for you to solve bugs and get them out to customers as fast as possible? So these are words that are also guiding principles of what architecture you should use. It should be easy to scale it. It should be easy to test it, and it should be easy to maintain it. And you can't really say that one architecture solves all of these problems, because one architecture could be a really bad fit for your specific context, your specific use case. So all architectures have the ability to be really bad for these, with these factors, with these parameters in mind. So it's important to choose wisely for the architecture, because they are the expensive decisions that you don't want to change often in a system. So the modular monolith, which was the title for this talk, we've talked about the vertical slicing, and we talked about the horizontal slicing, and also the monolithic compared to distributed. So the modular monolith is an attempt. It's a strategy for combining a lot of the good parts about distributed programming and vertical slicing and domain boundaries. Take that concept, which is really awesome in many ways, and combine that with the simplicity of having a monolithic system. You can split up the code base in a microservice-ish way and still have it as a monolithic deployable unit. This is the updated diagram of what I consider a modular monolith is. You have the vertical slices, you have the domain modules, the boundaries that they are in, and they all have a public API, which could be anything from simple method calls to asynchronous messaging, and all of the communication between them goes through this public API. But the big thing is that these modules, they are independent and they are cohesive, meaning that they are structured. The content of a module is cohesive. That it makes sense that they are together. It should be a part of the system that is somewhat isolated, and that the communication in and out of this module is very clear. It's simple, and it makes sense. So you can have the user module, for example, that handles anything about users. You can have order service that handles anything about ordering stuff. It should make sense, and defining these domain boundaries is sort of the basic requirement for this. because you can have a modular monolith, you can have a vertically sliced system, but if your domain boundaries does not reflect the actual communication paths that exist in the product, then this very quickly will turn into a big mess, and just you're back to a big ball of mud monolith again, because nothing is really structured. So having these boundaries defined and having them isolated in communication is the key to designing a good modular monolith. The pros of modular monolith is that the simplicity and the domain-driven design policies, or the process of defining domain-driven domain-driven systems is the core of the design, and that is a really big topic, domain-driven design. Just that. So I encourage you to read a little bit about that. But this is sort of one of the core concepts of of the modular monolith is this domain-driven design. And performance, I mention it because if you have two modules that need to communicate, having them communicate in process, just with maybe a simple method call, or maybe an in-process event system, a message system, because everything is in process, it will be faster than any network-based communication in most cases. So it's a performance. It's easier to, if you don't have the network as a factor, then you will see the performance benefit with this approach. And testing and debugging, you have one big monolith, so you don't have to worry about testing multiple services that are hosted on multiple different processes, or maybe even networks. Everything is nicely compacted into one big monolith. So testing and debugging, making sure that the communication paths go the right way, it's simpler than any distributed network can do. If you have just everything is at the same place. But the scalability of monoliths in general is a factor. Distributed computing you can have just a small part of the system that needs to scale a lot. It's free to do that. You can have automated load balancing based on CPU time, CPU usage, and bump everything up that needs to. But scalability of monoliths is a negative. It's a trade-off. I mentioned it a little bit in the last slide about module coupling. So if you have a modular monolith, if you have a monolith in general, then over time it has a tendency to when new people join, old people leave, the product evolves. And a monolith is inherently, it's sort of susceptible to this sort of breaking of the dependency of the communication layers. And modern IDEs for, I guess, Java, you guys use Java a lot of you, and I'm working a lot with .NET and Visual Studio Code. All of the modern IDEs, it's very handy and very nice to suggest, like, oh, you want to use this method? It's in this part of the system. Do you want to add the reference? Yes, I want to. And then a couple of years later, you have a lot of these sort of ghost dependencies that sort of use stuff in the wrong place. And when you have a monolith and everything is deployed together, then they can be really hard to track down, to have these sort of wrong direction communication in the monolith. They can really sneak by without anybody really knowing. Distributed computing is a lot more cleaner because they're actually different processes and they're over the network. So any communication is really controlled, and it's a lot of infrastructure around it. So module coupling over time is, of course, a factor that is part of maintainability. But there are tools to help with this. I have that later as well in the slide about how to prevent this type of sort of degradation over time. Technology lock-in is, of course, it means that you're kind of stuck with whatever language and infrastructure that the monolith has. You're basically sort of stuck with a lot of it, and it's really hard to, or it's harder to have different domain modules, really completely being anything different. So having a .NET project, and then you want to have a Java-based module, you want to have a Python-based module. That's communication between all of these different types of language stacks. It's going to be hard inside a monolith. Maybe possible, but it's going to be cumbersome, of course. So technology lock-in, negative, and just in general, that you have a shared code base. Just in general, it has the danger of it over time that because everybody's working on the same code base, then you could have merge conflicts. If you have part of the system that are shared, merge conflicts because everybody's working on the same stuff together all the time. It's going to be scalability in terms of number of developers is a factor here. You want to, if you start the system with just a small number of developers, but then after a couple of years you're up to 100, 200 developers. Having everybody work in the same repository, in the same code base, merging everybody to the same master branch for deploy, going to be challenging. It's going to create problems of developer scalability that you need to solve in that scaling process. If you've ever worked with a repository which have a lot of people working all over the place, and maybe you also have teams that are the teams are not really organized isolatedly. All of the teams have a combined, like a communal responsibility of the whole product. And so that you can have one team, and you can have two teams working on the same part of the system at the same time, just on two different tasks, because that's higher priority. The merge conflicts when you have two teams working at the same time. Yeah, if you've ever experienced it, you know the pain of that. A lot of days goes wasted just for merging conflicts. The modular monolith, it tends to, you don't want, to make it simpler for you, you would want to have the teams structured around the modules as well, so that you try to avoid the pains of conflicts. So doing it as microservices as possible without actually being microservices, and that also includes the team structure. So let's say that you are a developer or an architect for a company that has a big ball of mud monolith, and you are tasked with you want to fix the monolith. You want to say, yeah, we don't like that it's expensive to change, that every change we do breaks something somewhere. We want to modernize it. We want to make it better. We want to make it easier to work in. A normal thing would be to look at microservices, because breaking a monolith up to microservices is something that a lot of people are doing right now, and it's a hard thing to do. Not only to refactor the code into microservices, but it's a lot of infrastructure stuff that needs to be put in place. But before you do all that, then the most common way is to think that, okay, I have a big monolith system. What should we break out into microservices, or what should we clean up and make better and make easier, modernize? So defining domain boundaries is like the core thing that you want to do when you're migrating from a big ball of mud monolith it's a mess into nice, clean domain boundaries. Then event storming is a strategy that is commonly used for this. It's basically a workshop thing, that in-person workshop thing, that you take stakeholders. You have developers, architects, POs, testers, everybody, business analysts. Everybody gets together and you talk about the different user flows in the system. You have like a user is logging into the system. A user is placing in an order, and they're clicking, they're buying something. They want to pay what's in the cart. You have all of these user scenarios in the system that they are doing now. If you have an existing system, then basically what is the system doing today? And if you can take all of those user scenarios, you put them on a post-it note, each scenario on one post-it note, put them on the wall, on a wall, and then hopefully if you have a big system, then it would be a lot of post-its, like a big wall of post-its, and then you try and organize all of these post-it notes into sort of groupings, categorize them in some way, so that you have the user login and user change password. Yeah, all right, they seem to be somewhat related. Let's put them together in this quarter, and then you have placing an order and paying for an order, maybe. Yeah, all right, these seem to be roughly the same sort of domain. So you take all of the post-its and you try to define them into bigger categories. And when you're done with all of that, then maybe you should have sort of roughly a design of what are the domain boundaries in the system. What sort of makes sense for the product to be together and not be together. when you've done that, you say, all right, let's do something simple first. Let's do a small thing. Let's do the login module, or the user login authentication module. Let's start with that because it's pretty simple. It doesn't have a lot of post-its from the event storming workshop. So let's try and extract that to a microservice. So you take the code, you modernize it, you try to put it into a separate code, something that is easily deployable, and the strangler fig pattern that I mentioned here is a strategy for extracting things from an existing system, and adding them to the system, but also making them like backwards compatibility with the old stuff. It should be a factor when modernizing part of the system. But basically, strangler fig is that you take small bites of the big monolith, the big system, small bites, and you convert them, and then you deploy everything to production with this little small part extracted, and you have to. All of the communication to and from the module needs to be handled, so that all the old communication in the old code that was maybe just method calls converted into network communication, and you close down the old part, and you update the system, and you add the new microservice, and you send it to production. And this sort of the first small step towards converting a monolith to a microservice. And deploying to production, there are many different strategies. I'll mention a few here. Basically, they are all meant to sort of simplify the process of taking part of the system and a part of the system, updating it, and then sending it out to customers. So it's a fast process to to taking a part of the system and updating it to a microservice. Partial rollout, just a smaller amount of people get the actual new version. Feature toggling, of course, and canary release. People can opt to use the modern version, and parallel run, having the old and new running at the same time. A lot of different strategies on that, but the main thing I want to mention with this, the sort of takeaway from this, is that when splitting up a monolith to a domain-driven design, then the first step is to define the domain boundaries. What domains exist in the system? And if you're creating a new system, then just to talk about the features, the requirements that you want for the system, and you define these domain boundaries. And then you take them small steps, especially when converting from monolith. You take a small bite and convert it and send it to production. And because when you've gone all the way of actually production, releasing it to production, there's a lot of problems. The one thing to just change the code, but it's another thing to actually make it production ready. When you've done a small part to production, hopefully you learned a lot about the process of how you would do it, what works well, what doesn't. So the module number 2 that you want to extract, or the microservice number 2, should hopefully be easier to do, because you've solved a lot of the initial problems with the first one. So a strangler fig pattern, good thing to Google. It's a solid approach of converting big systems to smaller systems. But I'm not talking about microservice architecture in this talk. I'm talking about the modular monolith. And what I want to highlight with the microservice approach compared to this is that they're basically the same thing. The important stuff about converting to microservices is defining what should be in the module, what should be in a microservice. And it's basically the same strategy for modular monoliths. The difference between modular monolith and microservices, it's surprisingly small difference. It's conceptually, the structurally of the product as a whole is very similar, and that's a good thing. That's domain-driven design, modularized, isolated modules with high cohesion and low coupling. That's sort of the buzzwords for what microservices and modular monoliths are. But the prioritization if you do a monolith, it's easier for you to prioritize code quality and maintainability, and actually focusing on the code itself and not all the infrastructure that you have to do when doing microservices. You can focus on what I think is the important stuff, which is developer experience, and actually enabling developers to do a good job and be able to do good work and solid work that is with a high rate of tests, of high coverage of tests, and just in general be proud of the code that you write. So if you focus on that and not about the microservices, scalability and elasticity and all of the buzzwords that are accompanied with microservices, that's sort of the main thing, the reason that I want to talk about this is that I think that a good domain-driven designed monolithic system is a solid way to host the system for a lot of use cases. And you don't have to do microservices to have the values that microservice design, overall design, could bring. And the monolith first movement is a really good thing that I really want to sort of sell with this talk. There is a man called Martin Fowler, which is a big name in software engineering and software architecture in general, and he is a big champion of the monolith first approach. And I'll talk a little bit about more him later here. And also because the last part here about migrating to microservices, one of the big things about microservices and modular monolith, they are so similar in the way they structure the code, is that you can actually have the modular monolith as a stepping stone to microservices. You can have this big ball legacy monolith, and you want to do it more. You see in the future that, yeah, we want to do microservices. We want to have all of that microservice architecture enables you, but it's a big step to go there, and you have to solve a lot of problems with microservices. So if you instead focus on the splitting up the system into nicely isolated domains, and with the event storming approach, or just splitting up the product, the big ball, into nice isolated domain boundaries, that's like the hard part of converting a monolith to a domain-driven design system. Though it will take a long time if you're migrating old systems, because it's hard to define everything into a domain. But if you focus on that, and you don't have to worry about all of the complexities with microservices, and still get a lot of the value about the structure and the quality and the isolation, the cheapness to change, all of those benefits, you still have those with the modular monolith. So migration to microservices is a great reason for selecting modular monolith. I mentioned Martin Fowler, and he is one of my heroes in this domain. And his thesis is that don't start with microservices. It's a lot to just do microservices. So you don't do it from the start. So the monolith first movement is basically you do a nice clean product in a monolith first, but then as the requirement for elasticity, for scalability that microservices bring you, when those requirements are prioritized and the monolith are not doing what it's not flexible enough that it needs to be, then you talk about microservices. Then you choose microservices because it's the requirement requires it, not because microservices is the best. Yeah, so this is the sort of the ending here, the last topic before summarization, and it's tooling. So I mentioned a couple of times that the drawbacks of monolithic systems is that they are usually, or they are oftentimes, one big code repository. You have one big code base in the same language mostly, maybe some differing sort of libraries between them, but it's going to be one big code base and one big monolith that is deployed at the same time. So how can you help developers in the future not creating a big ball of mud from a modular monolith? And there are some great tools that it's called architecture testing, architectural unit testing, or sorry, there is a word that I want to remember. I'm going to have to write it down so I remember it for the ReeTalk. It's anyway, architecture testing basically are sort of meta unit tests that doesn't really test the code itself, but it tests the product structure. So if you have the everything under the same project, and then you can create unit tests that checks the dependencies between the different. You have the jar files, or the Java projects or the .NET projects. You can check the relationships between them, and you can set up rules in the unit test that make sure that no disallowed or not allowed dependency errors or directions exist. So that is a good tool to use to try and help the longevity of the solution, the longevity of the maintainability of the system, and to set up a good architecture testing to avoid the sort of ghost dependency errors that could exist, that could prop up over time. I think especially when if the end goal is to go to microservices, but even in general, if you have the less coupling you have between modules in the monolith, the better. So if you can avoid having direct method calls between modules, because that is a sort of a hard coupling between modules. If you instead want to really go into the low coupling approach between modules, then having, even if they're in process, having them actually use event-based communication. You have say you have a user module that creates a new user. The user module broadcasts an event. Yep, I have created a user. If anyone's interested in that I've created a user, I just broadcast a random event, and anyone that's listening to it can pick that event up and say, all right, I'm interested. That is a very common way of handling communication in a microservice architecture, having these asynchronous events broadcasting and speaking. And that's the way to communicate between them. And you can also use this tool inside a monolith. I've only have experience with .NET in real term with this approach, and there is a package called Mass Transit, which basically it's an abstraction layer of event-based communication. So you can write, you sort of remove the specific implementation of one specific event system like RabbitMQ or Kafka or any of those. You don't focus on the implementation of the event system. You're just focusing on adding event functionality into the system, and then which provider of events of handling the events. That's basically just a plugin of the one you want to use. So Mass Transit is a great way of like abstracting the event system in .NET, and then you can choose to be an in-process message handler, which would be the simpler way of doing it in the monolith. But if you have microservices, then you just use the Kafka plugin that just fixes everything there. So hopefully there exists similar tools for other languages. This is not a .NET specific talk, but that's my experience. So I know more about that. But I did some Googling about the topic, and I know I've used reactive extensions in Java, in Android, and I know that is also a way of communicating. And there was something called Celery, which is the green icon, Celery, for Python, seemed to have some parts of this. So having a good way of creating asynchronous communication between modules, if you can do that inside the Modular Monolith, then you're going to have a good low coupled of modules that they're not dependent from each other a lot. And you also prepare it for a future where you have when you have microservices, because in microservices all the communication is sort of event-based or message-based over the network. So having the modular monolith already prepared for that is a good way of having it as a stepping stone for the future. So to summarize, I really believe in that the monolith is not just in the past. Monolith is a solid strategy for creating a system, either to start with or to have in production. There are many systems that are widely used that are monoliths. Stack Overflow, for example, is a great example. The number of users that they have, the amount of traffic that Stack Overflow have as developers, still a monolithic system. So monolithic system, it's not a problem for it being a monolith. the monolith is good for its use case. That's the important part. A monolith is a good fit if the requirements allow it, or it's a good fit for them. It's not monolith is not bad because it's old. And the domain-driven design processes and vertical slicing, those are the good parts those are really the good parts that microservices by default have, but you use them in a in-process monolithic context. And the lower you can have the coupling, as I just mentioned, the lower the coupling with asynchronous messages, the better for keeping coupling low. And high cohesion module, just making sure that the domain boundaries are correct. They make sense. But and the last part, they like microservices, but one deployable unit. So like it's yeah, they are definitely cousins in terms of what they are in code, but they are still from different families. The monolithic and distributed are very different in that regard. And whatever drawbacks the monolithic system has, it doesn't really solve them. Monoliths are not good in some ways, but microservices, distributed systems are also not good in some places. So monolith in terms of scalability of load balancing and elasticity in load balancing part of the system, it is a drawback, as with any monolithic system. And stepping stone to microservices, it's a natural sort of stepping stone between the monolithic ball of mud to a nicely separated distributed system. You just do a lot of the code, hard code stuff first, and then you can talk about the microservices. But I recently read a book from Sam Newman, which is a book for migrating monoliths to microservices, and he said a lot of companies they went the route of modular monolith, say that yeah, we're going to focus on that and we convert it, and then they realized that when they did that, everything sort of made sense again. It was easy to work in the system again. Some companies just stopped there and they accepted this. The modular monolith was enough. It fixed a lot of the problems that they had. But microservices were not the answer. Good domain-driven design, that was the solution for their problem. I have some resources I want to share. I have recently got a course on a developer, Milan Jovanovic, that has a really excellent course in detailing, detailed implementation details about this architecture. And it is in .NET, so it's maybe not relevant for anyone, but if you're in the .NET area, then it's a really great course. And Simon Brown is another big proponent. He's a author and a lecturer, also a big proponent for modular monoliths. So anything with him is something I recommend. And the Sam Newman book that I mentioned, it's really good. And I like that book because it's sort of you can really just swap the microservices to a modular monolith, because a lot of the challenges with converting monolith to microservices is the same for a modular monolith. And then I linked to Martin Fowler, sort of his article about the monolith first movement. All right, I think that's it for the presentation. So questions, Hambia, I saw that you joined. Welcome.
Yeah, thank you. I mean, looking at the big companies when they take a decision of going out to microservices, sometimes I think it's too much trend-driven. What is the most common mistake? Is it a challenge for people to explain what the real business impact is, or no? What is the most common mistake big companies make? Because I've seen them make that, and you had some kind of a quote there about you can't just go from a mess to microservices thinking that won't cost you a lot in maintenance, right?
Yeah.
But what do you think is the most common mistake in companies when they choose this kind of a strategy?
I think the biggest one is that in order to to have a good good microservice architecture that also requires that the teams and the company itself is structured around the same sort of domain boundaries. So if you have a big company with a lot of developers that are working on the same product all over the place, you have mixed teams and everybody is working on everything. That is not a very good organizational structure for microservices approach, microservice architecture. So it will be really hard for the product to be stable and good in the transition to microservices if the organization doesn't change with it. There is a great thing about there's a great a concept called Conway's law that is it defines that a software always mirrors the way that the organization that built it is structured. So if you have a big company with a lot of developers working all over the place, then the system will also reflect and be a big system with a lot of dependencies all over the place. But if you have a lot of small teams and each team are responsible for a small part, then the product will also mirror that. So it mirrors the communication paths of the system, of the organization and the system. So if you want to change from one to the other, then you need to change the company organization to match it.
Now you're talking a little bit about like reinvent this, right? So I mean that's also when you talk about modern systems or digitalization as a whole. The problem is not usually the technology, because there is always the latest technology, but it also needs to reflect how you are as a company. Are you prepared to change the way of working and so on? But I think that is not explained to the people that really lands with those decisions in the end. You're just driven by trends and technology. You just talk about the positive things. You forget to tend that who are we as a company? Does it make sense for us to even go there? And I've seen people even having the data points that you're talking about, still taking the decision because they left it to the more technology-driven people that is an interesting technology, but that impacted the company very negative. So what you're talking about here also about Monolith, you can go to a little bit modernize that as well, but still have some of the advantages. You don't need to go to all the steps and so on. So I think that is an important way that you express this. The more business leaders should have it explained like that, because that would make more sense for them to understand what kind of decision they need to take.
Yeah.
So thank you for a good presentation.
Excellent. Anybody else? Okay. I'll stop the recording. Thank you guys so much.